The diagram below shows the graph of y equals f of x and 4 key points on the graph a, b, c and d. We want to state the images of a, b, c and d, which are called a dashed, b dashed, c dashed and d dashed, under each of the transformations below. And we can see that first transformation is f of x plus 3. Now think about this one. That one is a vertical translation 3 units upwards. So what's that going to do to the coordinates? Well, the x coordinates are not going to change if it's vertical, but all of the y coordinates will increase by 3. So if a is negative 8, 0, a dashed will be negative 8 because the x coordinate will stay the same, but the y coordinate increases by 3. So by the same token, this one is going to be negative 5, 12. This one will be 0, negative 1. And this one will be 2, negative 3. Now f of x minus 2 we should recognize as a translation of 2 units downwards. So all of the y coordinates will reduce by 2. So we get negative 8. Now remember, they're reducing by 2 from the original coordinates, not from the line above. So that's going to be negative 8, negative 2. Then we'll have negative 5 and 7. Then we'll have 0 and negative 6. And then 2 and negative 8. Now 3f of x, that's a vertical dilation scale factor 3. So once again, it won't affect the x coordinates, but all of the y coordinates will be multiplied by 3. And remember, once again, we're going from these coordinates, not the lines in the table. So negative 8 and 3 times 0 is still 0. Then we'll have negative 5 and 27, 0 and negative 12, and 2 and negative 18. Now, once again, this one here with the negative 2 multiplying the function outside, that's a vertical dilation. Scale factor negative 2, which is a reflection with a dilation. But all of the y coordinates, basically, you'll just multiply them by negative 2. So this one will stay the same because negative 2 times 0 is still 0. If we go to this one, that's negative 5 and negative 18. For this one, that's going to be 0 and 8. And this one here would be 2 and positive 12. Now f of 2x with the 2 directly multiplying the x, that's a horizontal dilation, and the scale factor here is going to be a half. For the horizontal, we always do 1 divided by the number just here. So this is going to affect x coordinates and not y coordinates. So negative 8, multiply that by a half, that's negative 4, and of course the y coordinate's not affected. For this one here, that's going to be negative 2.5, or 5 over 2, and 9. And then a half of 0 is 0 anyway, so that one's not going to move. And then the 2 negative 6 will go to 1 negative 6. F of negative x, we know that one is a horizontal dilation and the scale factor is negative 1. So that's going to affect the x coordinates. They're all going to become the negative. The y coordinates stay the same. So that's going to be 8, 0, 5, 9, 0, negative 4, and negative 2, negative 6. Now, f of x minus 4, that's a horizontal translation 4 units to the right. So all the x-coordinates increase by 4. So we get negative 4, 0, negative 1 and 9, 4 and negative 4, and 6 and negative 6. And this one here with the x plus 1 is 1 unit to the left. So if we move this one left, we get negative 9 and 0. This one would be negative 6 and 9. Then we get negative 1 and negative 4. And this one would be 1, negative 6. We've now got some combined transformations. So this one here is going to move us to the right 2 and up by 4. So the x-coordinates will increase by 2 and the y-coordinates by 4. So going here, that's going to give us negative 6, 4. Here, that's going to give us negative 3 and 13. This one would give us 2 and 0, and then this one would give us 4 and negative 2. So look at this one here. We have got a dilation, scale factor 2, and then 3 upwards. Now, both of these affect y-coordinates, so the x-coordinates will stay the same. So negative 8, then 0 multiplied by 2 is still 0, add 3 is 3. X-coordinate the same. 9 doubled is 18, add 3 is 21. X-coordinate stays the same. Negative 4 doubled is negative 8, add 3 is negative 5. And then here we double negative 6, negative 12, add 3 is negative 9. Now for this next one, these things are both inside the function, so they'll affect x-coordinates, not y-coordinates. Now if it's like this, where it's in a factorized form with the 2 outside, it does exactly what you'd expect. So in other words, we've got a scale factor 1/2 on the dilation, and then we move 4 to the right. So if we think about this one, that goes to negative 4 when we halve it, and then go 4 across to 0. Y-coordinate not affected. For this one, it's going to go to negative 2.5, and then 4 across is 1.5. For this next one, half of 0 is 0, then move 4 across. So that's going to be at 4, negative 4. And then for this one, halve it becomes 1, then add 4, so that becomes 5, negative 6. Now with this one, it's in unfactorized form. Now you can work with that, you just do the transformations in a different order, but personally, I prefer to always work in the same way. So what I would do is I would factorize that inside there, so that it's like that. And then I've got a dilation, and then we move 2. So this one goes to -4, then move 2, so that's -2, 0. Half it, so that's -2.5, and then add 2, -0.5, 9. This one, halve it and it's still 0, add 2, so that's 2, -4, and then for the final point here, 1 and then add 2 is 3, -6. Now if we look at this one, we've got a horizontal dilation, scale factor -1, or a reflection in the y-axis, and the 3 is outside, so that's going to affect y-coordinates. So we're going to go downwards by 3. So the -8 is going to become 8, and then this one, 0, is going to become -3 because we move downwards. So this one becomes 5, and we move downwards by 3, so that's 6. 0 will stay exactly where it is, and then we're going to move downwards, and then finally this point here would multiply by -1, so it will move across to -2, and move it downwards, so that's -9. 3f(2x), so the 3 being outside is a vertical dilation, scale factor 3. The 2 inside is horizontal, scale factor half. So x coordinate is going to become -4, y coordinates 3 times 0. Then for this one, we're going to get -2.5 and 27, 3 times the y coordinate, 0, and 3 times this is -12, and then finally here that's going to become 1 and -18. Now this last one has a bit of everything going on. So we've got -2f of 2x minus 1 add 5. So the stuff inside here is going to affect the x coordinates, and notice that we do have it in the factorized form, so that's great. And so we're going to get a scale factor of 1/2, and then the -1 means we're going to move 1 across. For the y's, we're going to have a scale factor of -2, and then we're going to add 5. So let's think about the -8. That's going to become -4, and then 1 across is -3. For this one, that's going to become -2.5, so then 1 more across is -1.5. The 0, or half that and still 0, and then move 1 across, so that's going to 1. And then for this one, we half it to 1, move it by 1, so it goes back to 2. Then let's look at the y's. 0 times -2 is still 0, move it up by 5. This one here is going to become -18, add 5, -13. So for this one here, we're at -4, so that will go to 8, and then add 5 is 13. And for this one here, -6 multiply that by -2 gives us 12, add 5 is 17.